Hello everybody, I am SM and today in this video I'm going to tell you about Thevenin's theorem, rather the application of Thevenin's theorem in any of the basic questions that we face. See, starting off with this question, that is, determine current in 4 ohm resistance using Thevenin's theorem in the following circuit. Over here you can see a circuit with a 27 volts battery. Then you can see a 3 ohm resistor, after which we have a current source as well of 3 amperes, then a 6 ohm resistance, then a 4 ohm resistance. Now see, over here when we start off with the question of determining the current in 4 ohm resistance using Thevenin's theorem, our basic idea is to use this theorem specifically for solving this question. Now, over here we'll follow a number of steps, starting off with the first one. The first step will be to remove the load resistance. Now, the load resistance is the one across which you want to find that current. Over here in this question, you can see that the load resistance is 4 ohm as specified. So, the first thing that we know over here is that load resistance is 4 ohm. Now your first task over here comes up to be to remove this. So our circuit that would change will become something like this. See, so this is a circuit that we have obtained. Now, we have removed that load resistance from here, so we can suppose that it's somewhere here, maybe, but specifically saying it's not a part of this particular circuit. That means now we have to deal only with this circuit, we will not include this, so we do not need it right now. So we are done with the first task of finding RL. Now a second task is to determine the current in this circuit. Now that is done by marking the current in different branches of the circuit. We start off over here with this. See, this is the battery. So of course we are going to start off with the current from here. See, over here we can mark this as I. Now, as we have start off our marking, so the same current is going to flow over here as well through this 3 ohm resistance. Now we can see over here that we have a current source, which means that over here a 3 ampere current is flowing, and in this direction of course. So when the current meets at this point and flows in this branch of the circuit, it flows with this value I plus 3. Now the important thing over here that you need to see is that because this particular section of this circuit does not has a resistance involved and it's an open circuit, which means that no current flows through it, which means the current on a whole I plus 3 flows directly through this 6 ohm resistance and no current flows through this. Now again, as this current flows, again it will not go in this, so it will flow in this direction, and that's how we have determined the current in each stream. Over here it will be I, because I plus 3 then minus I, opposite direction, so we get on a whole this as a current. Over here that's I. Now see, the next step is to determine the equation, or to tell the equation as which will be formed. Now over here we can see that because the same current I flows in the whole circuit, so we need just one equation to solve the problem. So the equation will be, now we can apply KVL in any of the loops, but we would preferably want to do it in this loop, in this direction. Fine. So we start off with the equation as 27 is equal to, because this is a voltage, so it will be equal to 3I. Then as we further see in this loop, this is the equation that we have got over here. Fine. So this implies that is equal to 3I plus 6I plus 18, 9I plus 18, 27, which implies that it's 9 is equal to 9I, which further implies that I is equal to 1 ampere. Fine. This is how it is. So this is how we get this is equal to 1 ampere. Now, after this, after determining the current, now this is a current which is flowing in this whole circuit. Now, individually, if you want to find the current of a 4 ohm resistance, we need to follow some more steps. As it is, we are done with the first one. Now, this second one. The third step is to determine VTH. Now, what VTH is exactly? See, VTH is, if I write over here, VTH is the Thevenin's voltage. Now, why do we call it Thevenin's voltage? Now, this, because of course this is Thevenin's theorem, so we call it VTH, that's Thevenin's voltage. But the point is, what is it exactly? See, it's the voltage that we assume a voltage source to be here, because we feel that a potential difference will be created over here if we mark them as A, B. So we do believe that a voltage difference will be created. So we assume, and thus we have a voltage over here, and we denote it with VTH. So now our next aim is to determine what VTH is. Now see, as it's correct enough that we want to determine VTH, but for that we can have any of the loops being used. If you want to use this loop, this, or you can use any of the loops. But now, because VTH is to be found or determined, we would prefer this loop as it's the voltage across this resistance. Fine. So for determining VTH, like I'm symbolizing it with this, like this is the section wherein we are finding VTH. So VTH, we can put the equation as 6I plus 3 is equal to VTH. So this is how we have put the use the loop law over here, and we have found this equation. Now we know the value of I is 1 ampere, so we can put it over here. 1 plus 3 is equal to VTH, which implies that V into 4 is equal to VTH, which further implies that VTH is equal to 24 volts. Now our next task over here is to determine RTH. Now RTH is basically the resistance which is of the passive circuit, which means it excludes RL. Rest all the things are the same. The only thing that's excluded is the RL. That is, this is a required circuit. We remove this, but this time when you're determining RTH, that is the Thevenin's resistance, it only takes into consideration the resistances which are present. That means we short this with the voltage source, and we make this current source is we change it into an open circuit. Fine. So the next circuit that we get over here is this. See, let me draw it. Now this is a circuit to determine RTH. See, we have converted this current source into an open, and this is the resistance. This was already open and this has been short circuited. So we get this is 6 ohm resistance and this is AB as we marked. Now see, and we can even mark the currents. Over here this was I and over here we had I plus 3. Fine. Now see, so we now take into consideration this circuit. See, in this circuit you can see that our basic aim is to calculate RTH. Now, as a basic aim is to calculate RTH, we would start off with calculating the net resistance, which is basically the motive behind finding RTH. Over here you can see that both of the resistances have different currents, I and I plus 3, which means of course they are in parallel. So the net resistance that will be, or we can say RTH will be 3 into 6 upon 3 plus 6 upon 9, which is 2 ohms, which implies that RTH is equal to 2 ohms. Fine. Now, coming to the last step. So before actually summing it up, we must write once again what all results that we have got till now. See, the first one was RL, the second one was VTH, the third one was RTH. Fine. See, RL was 4 ohm, the load resistance. VTH was, once again, 24 volts. And RTH is 2 ohms. Right. Now our main aim of the question, that was to determine the current in 4 ohm resistance. See, while determining current in 4 ohm resistance, we'll apply the formula, which is the basic formula, or we can say the basic formula being used while applying Thevenin's theorem, that is VTH upon RTH plus RL is equal to I. So over here VTH is 24, RTH being 2 ohms plus RL being 4 ohm. This is 24 upon 6 and thus we get 4 ampere as a current. Therefore, I is equal to 4 ampere. That is 4 ampere current is the required current which flows in the 4 ohm resistance. And this is how we have solved it. So let us once recapitulate the whole thing. See, starting off from here, our basic aim was to determine the current in 4 ohm resistance. Fine. Using Thevenin's theorem in the following circuit. Now, our initial circuit was this, like you can see over here, wherein we had a 3 ohm resistance, a 6 ohm, a 4 ohm, and we were supposed to find the current through this particular 4 ohm resistance. Now, our first step was to determine what was the load resistance, and we could do that by knowing as it was mentioned in the question. Fine. Now, after this, our next aim was to determine the current in this circuit. Now, in this circuit, you can very easily see that as we have shown as well, over here current I was flowing, over here 3 ampere current was flowing, so it adds up to I plus 3. After that, we can see that because in these two branches the current does not flows, because these have been open circuited over here, which means no current will flow through them. That's why the whole current flows directly through 6 ohm resistor. Now, this is the resistor that we have actually bifurcated from the main circuit. So it's over here, and we're not including it in the one that we are using for calculation purpose. So this is how we get our equation by applying KVL. That's 27 is equal to 3I, like 3I, and then plus 6I plus 3. The whole circuit that we're considering, the loop that we are considering over here is this one. Fine. Now, after this, we find this is what the current was, 1 ampere. Now, next aim was to find VTH. Now, While finding VTH, we had seen that it is 6i plus 3 is equal to VTH. This was again found by applying a loop over here, which we can easily see 6 into I plus 3 is equal to VTH. Now over here we have put the value of I, which we had found over here. So it's 6 into 4, that's 24 volts. That's the required voltage. That's VTH. Now coming to the current, we have again another circuit. Now this was for not for current but for RTH, which will result in our finding for the current across 4 ohm resistance. So over here you can see that in this particular circuit we have short circuited the voltage part and open circuited the current source. So over here we have a 3 ohm resistance, a 6 ohm resistance, and the current of course flowing in that circuit. So we find RTH. Now we know that both of them are in parallel as the current flowing through both the branches is different. So we find the RTH, that's 3 into 6 upon 3 plus 6, 18 upon 9, that's 2 ohm. So that's the RTH. So the values that we have over here are, we have found RL, VTH and RTH. Now finally the thing that we need to do is to find the current. I is equal to VTH upon RTH plus RL. This is the basic formula used, or we can even think about it as, while we apply the Ohm's law, we have V is equal to IR, right? So this is the voltage, or we can even say that it's V by R. So over here the net voltage was RTH plus RL, because RTH was the net voltage, the net resistance across this circuit, and RL again being in series, so we have added it, and VTH was the voltage of that circuit. So in a way we are applying Ohm's law according to the circuit. So I is equal to VTH upon RTH plus RL. So this equates to 24 upon 2 plus 4, 24 upon 6, that's 4 amperes. So finally the current that's flowing through 4 ohm resistance is 4 amperes. Thank you for watching the video.